Hi guys, welcome to a new video on differentiation under Math SL. We shall continue with our review series. This is the third video in the series, and as we said before, each video presents questions that are slightly harder than the previous video. So this is about the intermediate difficulty level. So these are questions that are not very easy to solve, but also not extremely advanced. So I shall be tackling the 4 questions on the screen in front of you, and I shall begin question 1 shortly. So question 1 came in paper 2, November 2001, time zone 1, question 7i. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So in question A, we are given the function y equals 3x minus 2 over 2x plus 5, and we are required to write down the equation of the vertical asymptote and then the horizontal asymptote. So the vertical asymptote has to do with the values of x that are not allowed in this equation. And this usually has to do with one of two things. Either a value of x that would make the denominator of a fraction equal to 0, or a value of x that would make the value of the expression under a square root negative, because we know that you cannot have a root of -5, for example. So if a value of x in a function were to make the expression under the root negative, that would not be allowed. If we have a fraction, then the value of x that would make the denominator 0 is not allowed. And by not allowed, I mean that the function is asymptotic to this value of x. At this value of x, the function exhibits asymptotic behavior. It never touches this value of x. It only approaches this value of x. So for further reference to this type of question, you can check the videos on functions. So this is a different topic. Anyway, so to write down the equation of the vertical asymptote, since we have a fraction here, I need to check which value of x would make this denominator 0. Hence, I set the denominator to 0 to find x, which is what I've done right there. And you can see that the value of x that would make the denominator 0 is -2 over 5. Hence, the equation of the vertical asymptote, which is a vertical line, is x equals -2 over 5. You cannot just write -2 over 5 because this is not an equation, this is a number. You need to write x equals -2 over 5 because this is the equation of a vertical line. So moving on to double I want to find the horizontal asymptote. So the way I try to find the horizontal asymptote, there are different ways to do that. My preferred way is to set the x as a very large number and find the value of y. So if I set x as, for example, 3,000 or 3 million, and we have another x in the denominator, so this will be 2 million. If x is extremely large and we have a very large number here, this value becomes negligible. 3 million minus 2 is a very large number that is very close to 3 million. Similarly, 2 million plus 5 is a huge number that is extremely close to 2 million. So 2 million and 5 is almost 2 million. Hence, if we substitute x with a very large number in the numerator and the denominator, approximately we shall get 3 million over 2 million, which is 3 over 2. So since this is a paper 2 question, we can afford to show this using the GDC, which I shall do right now. So I've written down on the calculator 3 million minus 2 divided by 2 million plus 5, and this is the answer I got, which is 1.49999, which is approximately 1.5. Of course, we know that 1.5 is the same as 3 over 2. However, I recommend that you become aware of this even without the use of a calculator, because if this comes in paper 1, you cannot resort to a calculator to solve. So you just set x as a very big number and try to imagine what happens to y, and the value that you get is the equation of the horizontal asymptote. Again, you cannot just write 3 over 2, you have to write y equals 3 over 2. So in B, you are asked to find dy by dx and to simplify as much as possible. So this is a quotient rule problem, obviously. U is the numerator, 3x minus 2, v is the denominator, 2x plus 5, u dash is the derivative of the numerator, which is 3, and v dash is the derivative of the denominator, which is 2. So we plug them into the formula, vu dash minus uv dash over v squared, and we expand the numerator to simplify. So I distributed the 3 over the bracket and the negative 2 over the second bracket, and I simplify, getting 19 over 2x plus 5 all squared. Next, in question C, I am asked to find the number of points of inflection of this function. So we know that the point of inflection is defined as the point where y double dash is 0. So I shall differentiate this expression right there to get y double dash. In order to differentiate it, I've rewritten it here, taking the denominator into the numerator and switching the power from 2 to negative 2. This shall simplify the differentiation. I've multiplied by the old power and reduced the power by 1. Simple chain rule, and I've multiplied my answer by 2 because 2 is the derivative of the inside bracket. So 2 times 19 gives me 38. Hence, the second derivative is negative 38 over 2x plus 5 all cubed. So is this green expression ever going to be 0? Of course not. There is no value here of x that would make this expression 0. Hence, there are no inflection points. So this concludes our first question. Take a minute to write this down if you will. I shall begin the second question shortly. So the second question came in paper 2, May 2016, time zone 2, question 9. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So in question A, you are required to write down the equation of the horizontal asymptote of the graph of f. And as we mentioned in the previous video, the way to do that is to set x as a very large number and evaluate the value of y. You can do this using the calculator because this is paper 2. However, it can come as a paper 1 question, so get used to it manually. So if I set x to 1 million, for example, 1 million minus 1 is approximately 1 million. So what is 1 over 1 million plus 2? So 1 over 1 million is a very small number, 0.000001. So this number added to 2 is approximately equal to 2. Hence, setting x as a huge number here cancels out this term entirely, and what you have remaining is 2. Hence, the equation of the horizontal asymptote is y equals 2. So there is your answer to question A. I've set here x to 1,000. 1,000 or a million doesn't matter. And you calculate 1 over 1,000 minus 1, which is 1 over 999, or just 1 over 1,000, which is a very small number. Hence, your answer is approximately 2. Hence, your horizontal asymptote is y equals 2. Moving on to B. You are required to find f dash of x, the derivative of this function right there. So I've rewritten the function in a slightly different way. Instead of 1 over x minus 1, I've taken the denominator to the numerator and I've switched the power from 1 to negative 1, because this is x minus 1 to the power of 1. So it became x minus 1 to the power of negative 1. This shall help me with the differentiation. So if I differentiate this term, I get negative x minus 1 all to the power of negative 2, and this term is a constant, so it vanishes. Hence my answer is this answer, or in a better format, this answer, negative 1 over x minus 1 to the power of 2. So you are told that g of x equals a e to the power of negative x plus b for x greater than or equal to 1, and that the graphs of f and g have the same horizontal asymptote. Hence, the horizontal asymptote of g is the same as the horizontal asymptote of f, which we have found to be y equals 2. We are required to write down the value of b. So the way to approach this is to try to find the horizontal asymptote of g and to set your equation to equal 2, because 2 is the horizontal asymptote of f. So let's try to do that. Again, the way to find the horizontal asymptote is to set this x as a very large number. So a e to the power of negative 10,000 is 0, because e to the power of negative 10,000 is a very, very tiny number, 0.000001, for example. And this number multiplied by a shall give us a very small number as well. So this term cancels out. Hence, we are left with b. So the equation of the horizontal asymptote of g of x is y equals b. Since we know that it's the same as that of f of x, so y equals 2 is the same as y equals b. Hence, b is the same as 2. So if you try to evaluate e to the power of negative 10,000 on the calculator, you're going to get a tiny number. If you multiply that by any number instead of a, you're still going to get a tiny number. So a very small number added to b, assuming b is a regular number, like this question, 1 over 999 plus 2, so a very small number plus b, gives us b, just like this one gave us 2. So it's the same idea. So moving on to question D. Given that g dash of 1 equals negative e, find the value of a. So we are given the value of g dash when x equals 1, g dash equals negative e. So in order to find the value of a, what I'm going to do is I'm going to find g dash of x as an equation. Then I'm going to plug 1 instead of x and negative e instead of y or g dash. And I'm going to try to find the unknown. So since g of x is given by this expression, a e to the power of negative x plus b, g dash of x will be the derivative of this expression, which is negative a e to the power of negative x. And we are given that g dash of 1 is negative e. So we are going to evaluate g dash of 1 by setting this x to 1. And this gives us negative a e to the power of negative 1. So g dash of 1 is equivalent to this expression or this expression. These are two equivalent expressions. I've just taken the e to the denominator. And we are given in the question that g dash of 1 is actually equal to negative e. Hence, we can deduce that negative a over e is the same as negative e. So solving for a, I shall take this e from the denominator and multiply it to the right hand side, and I shall cancel out the negatives as well. So I get that a equals e squared. So moving on to question E. There is a value of x for 1 less than x less than 4 for which the graphs have the same gradient. Find this gradient. So if they have the same gradient, then I want the value of x that makes f dash and g dash equal to each other. So I'm just going to solve f dash equal g dash. So since it's the same gradient, f dash equal g dash, and we know that g dash of x is equal to negative a e to the power of negative x, knowing that a is e squared, so we are going to plug e squared instead of a, getting this expression right there. And we are also going to use the expression for f dash, which I've copied right there. And these two expressions are the same because the gradients are the same. So I need to solve these two expressions together, and I shall do so using the GDC. However, I've just done one simple algebra step to simplify things a little bit. E squared times e to the power of negative x, since they have the same base, I can just add the powers. So this is going to be e to the power of 2 minus x. 2 plus negative x, or just 2 minus x. And this negative sign, of course, just remains as it is. So I'm going to use the GDC to solve this blue equation right there. So I've written down my two equations right there. And I'm going to set my window according to the given interval in the problem, which was 1 to 4. The y values are achieved by trial and error, so we can just try these values that were already there and see whether they work or not. So there are my two curves. So I shall press on second, trace, find intersection. The first curve, so I want to find the intersection, which is roughly somewhere around here. So I'm just going to drag my cursor far to the left and press enter. Then drag my cursor far to the right, and then press enter, and then guess where the intersection is, somewhere here maybe. And the calculator tells me that the two graphs intersect when x equals 2 and when y equals negative 1. So bear in mind that these are the graphs of f dash and g dash. So when we are told y equals negative 1, this actually means that y dash equals negative 1. So we know that there is a point where x equals 2 and where y dash equals negative 1. So since the question requires us to find this gradient, so we are actually looking for the y dash, and from our graph we know that the y dash equals negative 1. So this is our answer. So take a minute to copy this down if you will. I shall begin the third question shortly.